Example B is another example of a rational inequality. We have the inequality x squared minus x minus 20 divided by x plus 1 is less than or equal to 0. To solve this rational inequality, I'm going to begin by finding my restrictions and my zeros. So the restrictions come from x plus 1 equal 0, or x equals negative 1. The zeros are obtained from solving the associated equation, that is x squared minus x minus 20 divided by x plus 1 equals 0. If I multiply each side by the LCD of x plus 1, that leaves me with x squared minus x minus 20 equals 0. We can solve for those solutions by factoring. The factors of x squared are x and x. The factors of 20, whose difference is 1, would be 5 and 4. We know there are different signs, with the larger one being negative. So we have factors of x minus 5 times x plus 4 equals 0. We set each of those to 0 to get x minus 5 equals 0, or x plus 4 equals 0. So the two zeros are 5 and negative 4. If we place those numbers on a number line, we have a negative 4, the restriction of negative 1, and 5. So there are actually 4 different regions that we need to test to determine where our function, so if this rational expression is of our f of x, where our function is negative or 0. Our intervals to test are negative infinity to negative 4, between negative 4 and negative 1, between negative 1 and 5, and 5 to infinity. Our test point, something to the left of negative 4, would be negative 5. Between negative 4 and negative 1, so maybe negative 2. Between negative 1 and 5, notice that 0 lies in that interval, so we'll test 0. And then to the right of 5, perhaps 6. Now our function, there's actually an interesting way we can write our function f of x, is x squared minus x minus 20 divided by x plus 1. Remember, I just factored the numerator as x minus 5 times x plus 4. And we're dividing that by x plus 1. If we can actually think of it in that way, it's going to help us determine the sign of the function, right? That's really all we need to know, is the sign of f of x. We can certainly find the exact value, but if we know the sign, we know if it's greater than 0 or less than 0. So if we plug in negative 5, we would have a negative 5 minus 5 times negative 5 plus 4 divided by negative 5 plus 1. Well, that's going to be some negative number, right? Negative 5 minus 5 is negative 10. A negative 5 plus 4 is negative, so we really have a negative times a negative in the numerator over a negative 4. Well, negative times a negative divided by a negative is going to be negative. So in that first interval, the sign of the function is negative. When we replace x with negative 2, we get negative 2 minus 5 times negative 2 plus 4 divided by negative 2 plus 1. Negative 2 minus 5 is negative. Negative 2 plus 4 is positive. And negative 2 plus 1 is negative. So negative times a positive divided by negative is going to be a positive value. If we plug in 0, 0 minus 5 times 0 plus 4 divided by 0 plus 1. 0 minus 5 is negative. 0 plus 4 is positive. And then we have a positive in the denominator. So a negative times a positive divided by a positive is negative. And if we substitute 6, we get 6 minus 5 times 6 plus 4 times 6 plus 1, which is a positive times a positive divided by positive. And that results in a positive value. So the only intervals that are negative are intervals A and C. Right, we want to solve where f of x is less than 0 or negative. So we're going to shade intervals A and C. Now, what about our endpoints? Can we include them? We can include where that function takes on the value of 0. It takes on the value of 0, add its zeros of 5 and negative 4. So 5 is included, we can put a bracket, and negative 4 is included. But what happens at negative 1? Negative 1 is a restriction, right? We cannot include it, so we have to have a parentheses at negative 1. So our solution set would be negative infinity to negative 4 with a bracket, union, parentheses at negative 1 to 5 with a bracket. Does that make sense? So instead of like actually plugging in and finding the number, you really just need to figure out what's the result of the number, if it's positive or negative. Now, I didn't have to put it in that form. I could have plugged into the calculator and gotten the precise value, but that's just a quicker way to do it. Speaking of the calculator, I have some screenshots that I want to show you and how you can actually use a calculator. So when you go to your y equals screen, right, your equation editor, you're going to enter the function. Be sure to put the numerator in parentheses, x squared minus x minus 20. Close those parentheses and then do divided by, in parentheses, x plus 1. Parentheses are very important here. So we looked at the equation, input the equation, then we're going to look at the table. So if you do second and graph, you'll get a table. And what values did I think about plugging in? Negative 5, negative 2, 0, and 6. So if I look at negative 5, negative 2, 0, and 6. Notice that my y value is negative. At negative 5, it's negative 2.5. It's a positive 14 at negative 2. It's a negative 20 at 0. And it's a 1.4, which is positive at 6. So it confirms what we just did. Also confirm the zeros and the restrictions, right? Negative 4 is a 0 because it has a 0 value at y. Negative 1 is a restriction because there's an error message. And 5 is a 0. So we're looking at, what happens around those numbers, around negative 4, negative 1, and 5. So we see that the function was negative. In fact, looking then at the graph, we have a negative 4 and a negative 1 and 5. So the function was negative before the negative 4, was positive between the negative 4 and negative 1, but it was negative between the negative 1 and 5, and then positive again. Right, so it's below the x-axis from what we confirmed, negative infinity to negative 4, and then from negative 1 to 5. Another way you can do this problem is you can actually input the entire inequality on the calculator. To get the inequality on the calculator, there is a test menu, so you have to do second test. I think that's the second math key. And so then you would just choose the appropriate symbol to get the less than or equal to, and then 0. And then you're going to graph. But when you graph, what's happening is either going to be a horizontal, actually it's going to be horizontal pieces either at 0 or 1. Think about a Boolean algebra. 0 means false and 1 means true. So think about where it's turned on or turned off. So for the interval to be true, or inequality to be true, it's going to shade the x values that satisfy it. So notice that it's shading from negative infinity to negative 4, and then it turns it off, and then it's shading again from negative 1 to 5. And so you can think about where those intervals are kind of highlighted is where the solutions of that inequality will be. So I hope that helps seeing another example and seeing how you can use the graphing calculator. So let me know if you have any questions.